Good morning, Dr. Shihabudheen. I'm Maliyekkal, and thanks a lot, sir. You gave me your time this morning, and welcome on YourPedia.
Yeah, thank you. Good morning.
Okay, Dr. Shihabudheen, it will be wonderful talking to you today because the areas in which you are doing your research, they are very, very relevant areas. To mention a few of your research domains, water and wastewater treatment is something which is very, very important. You are also working on advanced material for environmental protections and remediation, sustainable material for energy, especially civil engineering applications. You're also working on reuse and recycling of the materials, and also toxicity effect of nanoscale materials on conventional wastewater treatment. So these all areas are very, very relevant, Dr. Shahabuddin, for today's requirements, and especially for country like India. And Professor, you recently, one of your projects was recently also displayed in first ever R&D fair, which was held in IIT Delhi, 14th and 15th of October. That project which was displayed, the name of that project is Capacitive Deionization Unit for Clean Drinking Water and Bio-derived Sealant, Eco-Nanoseal, if I'm pronouncing it correctly. And I'll be interacting with you on all these points. I'll be interacting with you on your research areas which are very relevant and about this project. So if you allow me, I can start our interaction now.
Sure, please go ahead.
Yeah. So Dr. Shahabuddin, whenever I invite person like you, my first interaction point is always related to your journey, academic journey, because most of the viewers on my channel, they are researchers and they look forward to pursue career, the kind of career you are pursuing. So they would always feel like knowing more about the speaker. So I request you to tell us briefly about your academic journey, how it all unfolded till you joined IIT Tirupati.
Yeah, thank you very much for the nice introduction. My name is actually Shihabudheen Mundamra Maliyekkal, in short, Shihabudheen Maliyekkal. I'm an assistant professor, Department of Civil and Environmental Engineering, Indian Institute of Technology, Tirupati. It's 3G IIT. I'm an environmental engineer by training. I'm from a village called Arikod, located in Malappuram district of Kerala. This place is near to NIT Calicut, around 30-minute journey from NIT Calicut. I did my schooling in the same village and went on to do degree in Bachelor of Technology in Civil Engineering from NSS Palakkad, it's Calicut University. And after my graduation, I joined IIT Madras and earned my MTech degree in environmental engineering. After my post-graduation, I decided to continue my studies and wanted to solve some pressing problems countries facing. I joined PhD program at IIT Madras under the supervision of Professor Vijay Philip. She is an institute professor, belongs to Environmental Engineering Division, Department of Civil Engineering. The focus of my research was to develop an affordable solutions to remove arsenic and fluoride from groundwater. As we know, arsenic and fluoride are two significant contaminants of concern in groundwater, right? These contaminants are widespread, and the presence is detected in groundwaters of several states in India. And these pollutants are colorless and tasteless, so very difficult to identify their presence, right, by smell or taste. And as a result, millions of people, several millions of people drink contaminated water and exposed to these pollutants. So they are very toxic. So we have restricted the concentration in drinking water to safe value. For example, in the case of arsenic, it is restricted to 10 microgram per liter or 10 ppb. In the case of fluoride, it is 1.5 milligram per liter. So it is very important to bring their concentrations below allowable limit to achieve the water quality objectives. There are several ways through which we can, achieve this. but selecting or developing the right technology or solution is essential. And several factors we need to look at before doing this, including water quality parameters, the amount of water to be treated, the socioeconomic conditions of the affected populations, and so on. So we developed an affordable solutions to the problem. And after PhD, I decided to join with Professor T. Pradeep, Department of Chemistry, again IIT Madras. I was part of an IIT Madras incubated startup at that time.
Okay.
And our focus was to develop nanotechnology enabled water purification system and take the technology from lab to market. With that intention, this startup was incubated at IIT Madras campus. So we have developed solutions for arsenic and fluoride removal in water. So the startup company and IIT Madras have implemented this technology in the field now. And I think more than 1 million people benefit from this solution. So several places this technology have been implemented now. Okay. So after 2 to 3 years of associations with startup and Professor Pradeep lab, I decided to move to academics to motivate students and make them understand the importance of solving societal problem and need for developing, indigenous technology. So right now I am in charge of IPR, intellectual property right, and incubation cell at IIT Tirupati. And I'm actively involved in developing and an innovation culture at the institute. We have a group working on various aspects of water and wastewater treatment through sustainable solutions, right? Especially using nanotechnology. So we are also exploring, as you mentioned, other possible applications of these nanoscale materials, especially in the field of energy and building, repairing materials, and so on and so forth. So this profession gives me many opportunities to innovate and interact with innovative young minds. That's the beauty of this profession, and will not get this opportunity anywhere
else. That's true.
And especially in IIT system, right? So
Yeah.
you are dealing with the cream of students. So
that's true.
So IIT system is also relatively flexible, and that is another advantage compared to other state government universities, and so this is actually, and it's very flexible and open, and it's very essential for nurturing innovations and or innovative minds, right? Of course, we need to do much more and do everything possible to create excitement in students. That's very important. So that many people come forward to address various challenging issues that the country is facing. Yes. So it's also important to reduce dependency on foreign technology and achieve a national vision of self-reliant India. Yeah.
Dr. Shihabudheen, on the basis of what answer you gave, I want to ask you two things here. One is you were part of the incubation culture ecosystem which was developed in IIT Madras, and we know that IIT Madras is doing marvelous work in that particular area in the field of creating incubation centers and doing innovative research. And you also mentioned that you are working in the same domain in now IIT Tirupati also. So my question to you is what is the status of such kind of ecosystem in new IIT, which is IIT Tirupati? So incubation center and all.
IIT Tirupati is established in 2015, right? It's a relatively new institutions.
Yes.
So initially our focus was on infrastructure development. So this is one of the first 3G IIT, which has moved all its operations to the new campus. Now we are all staying in the new campus. All the academic programs are happening in the new campus. So I'm sorry. So our focus was more on infrastructure development. Now, the next 5 years, our focus is on innovation, startup, and things like that. As of now, we have a dedicated cell available here, and there is a center for sponsored research and consultancy. So under this center we have IPR cell and innovation cell, and we also have a Section 8 company to promote. Very recently, we have registered a Section 8 company to promote INE activities in the campus.
Okay. Dr. Shihabudheen, when it comes to the students or researcher who want to pursue their career in the field of academics and research, one dissonance is always in their mind, that whether they should become part of old IITs, which are having very senior professors and maybe already well established lab system and all, or they should be part of new IIT system, which is full of dynamics and full of young dynamic professors like you, and full of creativity and innovation and experimentation. So what is your suggestion to such students?
Yeah, so the both system has its own advantage and disadvantage. When you come to a new institutions, the good thing about new IIT is that so we have enough funding, from government of India to establish all this advanced facilities. And if you compare with old IITs and the kind of facilities that we have in new institution, it is comparable. And at the same time, the number of students working on a particular equipment or a particular lab, in a particular lab, it's very limited here. So the students will get much better access to these equipments. And we also have very dynamic young people in new institutions. They are really, wanted to do something. So this institute has its own advantage, but of course, the old institutes, the ecosystem, the culture is already developed. So that has its own benefit. So both has its own merit and demerit.
So, Professor, I can tell you on the basis of my experience that students, whether they join new IITs or old IITs, if the student is ready to learn and he's ready to put his effort, he can develop his career equally good, whether he joins this particular institute or that, because India has very enriched, environment in the form of IITs. Another thing which I found, a professor, in the profile of mentors or teachers of IIT system, I found that all the faculties or mentors or teachers in IIT system, they are working on some areas, research areas, which are very relevant to the problem of the society. As you also mentioned in the beginning, when you told about your academic journey, you mentioned about, okay, this is the problem and this is what we are working on. That is where you started and that is what you told. Now my question to you is, when a student does his masters, MTech or MS or PhD he goes into, so how he or she should identify which area they should work, so that at the end of couple of years of efforts, they come out with some solution which eventually benefit the society or industry or whatever. So how to identify that particular thing?
Yeah, so identifying a problem, it all depends upon the person interest, right? So there are several people who wanted to work on problems like this, which are very relevant, it's, problems, especially a country is facing. And there are students who are really interested in working on very fundamental problems. So it's all depends upon the student's interest, and as a faculty, as a teacher, our focus would be on to identify this and promote that interest, right?
Right.
So it's all depends upon the student's interest. Then our job is only to
Take them the
promote that and take them to the next level and give them appropriate guidance so that they will be on the right track.
right. Wonderful. So now I'm coming to our discussion on the project, professor, which was displayed in recent R&D fair that was held in IIT Delhi, and that was related to the project was capacitive deionization unit for clean drinking water and bio-derived sealants and Eco-Nanoseal. This is the domain. Now, in that particular project, it is related to wastewater treatment, and you have displayed two innovations there. One is related to wastewater treatment. The name is Pran Jal,
Yeah.
and the other is Eco-Nanoseal.
Yeah.
So this is used for repairing the micro cracks. So
Micro.
so Professor, I request you to please tell these two terms and about the project to all of us.
Okay. So, yeah, thank you for visiting this IIT R&D fair in our stall, and I hope you enjoyed
Yes, it was
various
wonderful.
products displayed in the fair, and I think it is the first of its kind, and
Yes,
very
it's a
successful.
good initiative, Professor. It must be annual ritual, but it's a
Yeah.
good initiative. Yes.
Yeah, so it's a very good initiative, and I hope the IIT will continue this kind of event in future as well. So as you requested, let us talk about these two projects. Maybe we can start with the Pranjal now.
Okay.
Pranjal is actually an emerging desalination unit and capable of removing dissolved ions in water. And this particular unit can remove ions very effectively. Unlike this conventional RO system, and this RO system, like the technology, this is here in the case of capacity deionization, unlike RO system, the technology used is very different. So right here we use kind of electrosorption process. In RO, or filtration process, right? So in capacitive deionization, we use carbon electrodes, and these carbon electrodes are used to electrosorb ions present in the water. Basically, what is happening here is an electrosorption process and not straining or filtration as in the case of conventional RO system. So when you look at the main part of CDI is an electrode cell. So this electrode cell consists of a bunch of electrodes stacked in series or parallel. For example, 250 or 200 LPH, liter per hour capacity unit, will have around 200 electrodes. Right? So let us take the case of a single electrode system. So this consists of an anode and cathode. So a positively charged and negatively charged electrodes, right? Now we can charge these electrodes by applying a potential across the electrode. And typically the voltage would be 0.8 to 2 volt, right? This voltage is called cell voltage. Now if we pass water through these electrodes, and we know that water has anions and cations, right? So water is electroneutral. So the anions present in water will get attracted to anode, and the cations present in water will get attracted to cathode. So the water coming out of the cell will be free from ions. So this process will continue for certain duration, say 2 or 3 minutes, right? So the absorption process will happen. So we'll get a clean water as permeate, and once the electrode is saturated, we need to regenerate the electrodes, because this material have certain capacity, right? So it can only hold certain number of ions. So once it is saturated, we need to regenerate the electrode. So normally we do this regeneration by reversing the potential, right? So during this process, what happens is that the this all electro-adsorbed ions will come out, right? Electrode desorption will happen and will come to the solution, right? Fortunately, this desorption kinetic is very fast compared to adsorption kinetics. So what we get is very small amount of reject. So that reject will go as a waste. So that's how it works. So it has an adsorption cycle, desorption cycles. So it's continuous adsorption, desorption happens. So that's how the water get clean. So we will have a clean water stream, and we also have a reject water stream. So as I mentioned, the good thing about here is the reject water would be very less. So because the regeneration kinetics is much faster than adsorption kinetics.
Okay.
So now once the cycle is over, now the next cycle will happen, right? The electrode, once it is regenerated, the electrodes are ready for the next cycle of adsorption. So this process will continue. So typically, electrode will typically what we use is a carbon electrode, and different forms of carbon can be used. So what we use is graphenic material because it has its own advantage in terms of large surface area, and we can control the porosity, and also we can decorate this material with different kinds of functional groups and so on and so forth. So this material has around 5 years and more than 5 years of life. Okay. So this material actually plays a significant role in deciding the performance of the system. So as I told you, in Pranjal, what we use is graphenic material with very high surface area, and it has a controlled porosity because this also decides the performance. So that's how it works. But if you want to use this kind of system in a real life situation, we need to have some sort of control mechanism, to control this adsorption desorption process. So we need to automate the entire process. So right, that's very important. So another important part of this Pranjal is an microprocessor based control system to control all this adsorption, desorption, regeneration processes. So these are the two important parts of this unit. And apart from that, we need pre-filters to take care of suspended solids, and we also need pre-filters to take care of non-ionic organic solids. So typically we'll have and also we need UV-C lamps to take care of pathogenic organisms. So this unit is actually integrated with all of this. It's a complete solution. So this unit, the Pranjal, is capable of reducing most of the pollutants present in typical surface and groundwater samples. But we also need to understand that the system is not suitable for seawater desalination, but RO system is even suitable for dealing with very high concentrated seawater. Like seawater will have around 45,000 milligram per liter of dissolved solids. Here what Pranjal can handle is maximum up to 3,000 milligram per liter, but it is capable of handling our surface and groundwater very well. So it's suitable for brackish water. Yes. Now we have incubated a startup at IIT Tirupati. This is one of the first startup incubated at IIT Tirupati. And with the intention of taking this product to the market, so one of my colleague, Dr. Saujit Sengupta, is the CEO of the company, and he's one of the founding directors as well. He also did PhD from IIT Madras. He was a PMR of fellow at that time, and in chemistry department. And now he is with us, and he's taking care of this particular initiative. Okay. So we have also installed these units in various places, including Amar Raja Batteries Limited at Tirupati, and Bosch Coimbatore, IIT Tirupati, and some places in Kerala, and so on and so forth. So this is about Pranjal. Yeah.
Okay. So, Professor, you are working closely with the industries, as you just mentioned in a couple of sentences at the end.
Yeah. So we are, these are the industries wherein we have installed this system. For example, Amaraja batteries, the system is, installed almost a year back. It is running very successfully.
Okay.
And now they are also interested to take this technology forward. And we have installed another system in one of the village with the help of Amaraja. So that is in Chittoor.
Okay.
And now we have a plan to install this system in several other villages in and around Tirupati, with the aim of providing clean water to all of them. So in collaborations with Amaraja Batteries Limited.
Okay. Professor, I was getting inquisitive to know about term Eco-Nanoseal.
Yeah.
So what is this term like nano? We know many terms related to nano, but what is nanoseal?
So this is actually, this Eco-Nanoseal is, a composite material. And it consists of a biopolymer. And along with the biopolymer, we have graphene oxides and derivatives. And there is a porosity controlling agents in that. And apart from that, we also have certain nanomaterials in it. So why we name this Eco-Nanoseals compared to conventional sealants? If you look at the market, what is available, they are all derived from non-renewable sources. They are acrylic-based or resin-based sealants and very toxic in nature. But this particular sealant is first of its kind, and it is derived from actually a waste material called chitins, right? And this chitin is transformed to chitosan, and it's a biopolymer. It is abundant and renewable, right? So that's how we name this product as Eco-Nanoseal.
Wonderful. So, Professor, I was going through your entire research work, and you are touching upon a very, very relevant society problem, that is wastewater treatment. So, my next interaction point is related to that only. What is the situation of wastewater treatment in India? What is the relevance of that? What is the requirement of that? And where do we stand today vis-a-vis availability of the drinking water in many of the cities in India? And what is the relevance of entire this wastewater treatment of the polluted water and all? So that is where, please spread your awareness on us.
Yeah, okay. So when it comes to water availability, we know that water is very critical, right, resource. And its availability at the point of use is actually a prerequisite for sustaining all forms of life on Earth. And we also agree that every aspect of our life is touched by water. And so access to clean water is a fundamental human right. So we have a lot of water on Earth planet. We all know that, right? The amount of fresh water, but this amount of fresh water is very, very limited.
Yes.
So we all know about it. It is around 2.7%, out of which what we need to understand is that a significant portion is away from human habitation. So they are all capped in ice glaciers and mountain, and it is not accessible for our day-to-day use. So what is available is very limited, and it's less than 0.3%. So that's what available. So we need to manage the entire freshwater requirements with this limited amount of. This monsoon.
Yes.
So this monsoon is actually, restricted to few months, right? 4 to 5 months. So we need to have an adequate storage capacity if we wanted to use all this rainwaters very effective. But we don't have adequate storage capacity. A significant portion of the water is lost, right? So we have very, very limited water available for managing the entire activities. So that's what we need to understand, that how precious this resource is. And on the other hand, if you look at the demand for fresh water is increasing day by day. Some estimate shows that the total demand for water would exceed the annual utilizable water by 2050. So the demand from industry, the demand from agricultural sector, the demand for drinking, all these are on increasing trend, right? So if you look at the per capita availability of the water itself, the per capita availability of water has significantly decreased over years. And now in various states, it has reached in a critical state, critical conditions. So anything less than 1,000 meter cube per annum per person shows the area is water stressed. And several cities in India, the availability is less than 1,000 meter cube per annum. So it's a very alarming, situation. Now we have a natural shortage, right? And this natural shortage is now further affected due to mismanagement. Mismanagement of water bodies and lack of adequate conservative measures. So both quality as well as the quantity of water have significantly compromised, significantly affected. So this is actually posing a significant threat to, to us, human as well as other living organisms. Now, when it comes to the pollution aspects, more than 75% of sewage is discharged untreated in our country. And this is actually one of the major reason for, I'm talking about domestic sewage. It's one of the major reason for pollution of water bodies, right? So if you look at the data, the installed treatment capacity that we have is around, so we are in a position to treat around 37% of the urban sewage, right? So now if you look at the actual data, around only 70% of the plant is functional, around 30% of the plants are not functional. So considering all this aspect, what we are treating is only 25% of the sewage. I'm talking about urban sewage. Rural domestic wastewater, most of the domestic wastewater go untreated, right? So 100% or 90% is not treated. So all these sewage is entering to our natural water bodies, and it is actually affecting the quality of the water. So this really demonstrates the bad situation in our country and the gross negligence in the field of treatment and reuse of domestic water. So what is needed is to have, we need to improve our treatment. We need to modernize our treatment plan. We also need to have more number of treatment plans so that we can treat more amount of, wastewater, because without treating wastewater, we cannot address, without having proper sanitations, without having proper sewage treatment facilities, it is not possible for us to address the problem of drinking water. So both are very much connected. Okay. Now we also need to understand that the waste generation is increasing, significantly. It is increasing exponentially. So if we continue this current pattern, we'll be generating more untreated wastewater in future, and the gap between the treated and untreated wastewater will increase. It widens, and that will further affect our water bodies. This is actually a very, very alarming situation. So we need to take adequate measures, to address this problem. Apart from that, there are several other issues that we can attribute for the bad quality of water, right? So issues such as practice of open defecation is one of the biggest problems, especially in rural areas and urban slum. And of course, discharge from industries and mismanagement of waste and lack of awareness also, right, affect the quality of water adversely. Okay. And this discharge actually from industries would continue, worsen, because many highly polluting industries are now moving from high income nations to emerging market economies. So lot of measures are required to address the problem in water sector. So providing clean water to all is a very challenging task. It's actually a mammoth task and very complex problem, because everyone is a stakeholder in water, right? And their preferences are very different. So lot of effort is required, dedicated efforts are required, needed for from all the stakeholders to improve the condition and secure a better future. So measures such as just treatment alone will not do the job. We also need to take other measures such as management and maintenance practice, good management and maintenance practices, waste conservation practices, right? Regulation of the use of water or groundwater. We need to monitor water, and all these are required. And proper maintenance, recycling and reuse of water is required. And of course, we also need to develop technologies, advanced and affordable treatment technologies to solve the problem very effectively. The problem is very complex and requires collective effort. So treating water alone will not solve the problem.
Sir, when you said that we already have very scarce fresh water resource on our planet, and they are also not in usable form, like you mentioned about icebergs and all. So I want to bring your attention towards potable water. Can we even categorize fresh water into potable or non-potable? Like, because drinking water is only very specific type of fresh water. I mean, if I talk about groundwater may not be drinkable, maybe. So I want to ask you that how this how much is the problem of drinkable water also. Like, when we take the groundwater and we use it in the kitchen, I'm sure there are pollutant in that. So though groundwater may be put in the category of fresh water, but it may not be put in the category of the potable or drinking water. So how severe is the problem? What are the typical pollutants in that, and how to resolve this particular problem of getting the drinkable water first?
Okay, so when we talk about fresh water, we categorize this based on the salinity, right? So we have saline water, and so that is around 97, more than 97%, and the fresh water that we are talking about is 2.7%. Then I also mentioned a good portion of that is away from human use, human habitation. So what is available, what I mentioned, is less than 0.3%. Now, if you look at this, out of this fresh water that we are talking about, 30% of that is again in, it's groundwater.
Okay.
And there's all that water, what we see in river, lake, it contributes only 1%.
Okay.
So, and 69% of this is, in glaciers, capped in glaciers. And so groundwater is actually is the main source of drinking water.
Okay.
And it is actually a more reliable and safe drinking water sources than untreated or partially treated surface water. So it is considered safe because it is not directly exposed to the outside environment, right? So typically, groundwater is free from pathogenic organisms. So it's also important, to note that this is the main source of drinking water and contributes 30%. But so large number of people in our country use groundwater as source of drinking water. So, but one of the primary concern, as you rightly mentions, with the groundwater is it has high, in several places, it has high dissolved solids, and some of the dissolved solids that we are talking about are toxics. Like, so we have arsenic, fluoride, and all these kinds of toxic pollutants in groundwater. And the main concern that we are facing with the groundwater now is it has high amount of dissolved solids, right? Any kinds of ions. Dissolved solids doesn't mean that all the dissolved solids are toxic in nature, but there is a limit for salinity also, right? And we also, if you look at the data, this dissolved solids concentration in groundwater is also increasing. So many factors can affect this, like groundwater age can affect this, geology can affect this, climate can affect, seawater intrusion, industrial activities, and pumping and excessive pumping and irrigation. All this can vary this groundwater salinity. So what we normally see, there is an increasing trend, right? The groundwater salinity is increasing. So it depends upon the geology, the type of rock present in the area, and the rock susceptibility to weathering. You will get different types of pollutants in groundwater, right? Most of the natural pollutants are coming to groundwater, like arsenic fluoride, mainly because of the weathering of rocks. So, for example, if a particular region has a lot of limestone, and in this area, even IIT Tirupati, we have a lot of limestones here, right? Normally, we get high calcium hardness in water. Here, the hardness in certain bore wells are as high as 500, 600. In some location, it is more than 1000 milligram per liter as calcium carbonate. So, in certain area, especially in Ganges Plain, we have arsenic containing mineral like arsenopyrite or orpimine. There are several arsenic containing minerals. So one can expect arsenic in water in this location. Similarly, fluoride, nitrate, etc. can also be present in groundwater. So, and other kinds of pollutants that you can expect in groundwater is manganese or iron and things like that. So we cannot say this groundwater is not suitable, because groundwater is the main source of drinking water, and without groundwater we cannot manage the entire drinking water needs, because that is contributes to 30% of the fresh water. But at the same time, we have all these kinds of issues in groundwater that has to be addressed. This is a significant concern. Even surface water is also significantly contaminated. As I mentioned earlier, more than 75% of the surface water bodies are contaminated with diverse pollutants, including organic, inorganic, right, and pathogenic organisms, biological pollutants, and things like that. So we have a very limited freshwater bodies now which are not contaminated, and most of these freshwater bodies are away from densely populated areas. So we cannot bring that water from there, because you need to spend a lot of money to transport that water. It's also not economically viable option. So as you rightly mentioned, without treatment we are not in a position to drink water, because it's already polluted.
Professor, I was going through your research work and I found that you are using a term called water footprint. Is this related to carbon footprint term which we use, or water footprint is something different?
If water footprint, it's see, this is like when we talk about development of any product or service, a certain amount of water is actually associated with that, right? And this concept was first introduced by Professor Ajan. So this is basically the amount of water utilized to produce a product or a service. So now, for example, if I wanted to produce 1 kilogram of wheat or 1 kilogram of cotton or anything like that, certain amount of water is required, right? What is the total amount of water required to produce and serve 1 kilogram of wheat on my table? So that tells the water footprint of that. So several thousands of liters of water is required. 1 kilogram of cotton requires something like 10,000 liters of water.
Okay.
So this water footprint is one way of looking at the carbon footprint also, like we'll tell you, but here we measure in terms of carbon equivalent, right? What is the amount of emission, carbon dioxide emissions when we develop something, right? So it is normally carbon footprint is estimated in terms of carbon equivalent, and the water footprint is estimated in terms of how much water is required for making a product or service.
Wonderful. So, Professor, now if I talk about this project itself, which you have done, though you have mentioned these terms earlier also, but I want specifically you to explain these terms once again. Your product uses a technology called capacitive deionization.
Yeah.
And this is in contrary to the conventional RO system. Please elaborate more on what is this capacitive deionization and how it is different from RO system. Though you have mentioned it earlier, but I want very specifically the difference to be demarcated.
Okay. So, as I mentioned earlier, unlike the RO system, in CDI, ions are removed through electrosorption process, right?
Yes.
In reverse osmosis process, the water is pushed through a RO membrane, as RO semi-permeable membrane.
Right.
And the membrane driving force here is hydrostatic pressure. So in RO process, we have a semi-permeable membrane. So this semi-permeable membrane separates polluted or concentrated water from clean or treated water. So we have a membrane on side, we have concentrated solution, and other side we have less concentrated solution. So when we separate two solutions of different concentrations with a semi-permeable membrane, so what happens there, difference in chemical potential will exist along the, across this membrane. So in normal condition, the water starts flowing from low concentrated, that means higher potential, to high concentrated solution. So we all know about this process. This process continues till this system reaches an equilibrium condition. That means, the pressure difference between this pressure difference will get balance the chemical potential difference, right? So this pressure difference balance this chemical potential difference. Until that this process happens, that means the flow of water from concentrated solutions to less concentrated solution. So we know that this balancing pressure is osmotic pressure, right? It's nothing but osmotic pressure. So now if we want to push water from concentrated side to polluted side, in normal condition it moves from low concentrations to higher concentration in normal osmotic pressure, right? Now if we wanted to push water from concentrated side, or polluted side to a less concentrated side. If we wanted to do that, we need to overcome this osmotic pressure, correct? So we need to apply more pressure than osmotic pressure across the membrane, so that we can achieve the flow of water from higher concentration, solutions to a lower concentration solution. So if you look at this process, in this process, water is separated from ions. We are not separating ions from water, right? Water is separated from ions. So a lot of energy is required to overcome this osmotic pressure, right? But now if you look at the CDI technology, CDI work based on sorption process. Here it is an electrosorption process. So these ions are picked from, or removed from water. So these are accumulated onto certain material, like electrodes, in this case, carbon electrodes. All right. Normally, we use carbon electrode for this purpose because it's very stable and more environmental friendly, and it has large surface area and things like that. So here the technology is entirely different, and the amount of energy what is required is significantly less. right? You just pass water through an electrode system. So the ions will be removed onto the anions will be removed to anode, and the cations will get accumulated on cathode. So it's a very simple process. And typically what we apply is a very small voltage to, potential across this electrode, that is around 0.8 to 2 volts. Typically 0.8, 1.2 volts. So that is the kind of voltage that we apply. And now, when we talk about this kind of a system, what is most important is to have an electrode materials which is having very high sorption capacity. So we need to develop material which is having very high sorption capacity, and that material should have certain porosity, certain ranges of mesopores and macropores, and good conductivity. And all of these are extremely important to make a good electrode. So that's where we need to invest time so that we can improve the performance of the system. So as of now, if you look at what this CDI technology, it is not capable of removing, capable of desalinating high concentrated solutions, not suitable for seawater desalination and all. So, but this can also be achieved over a period of time. There are certain type of CDI system. We are also started working on that. The flow electrodes, carbon electrodes, which can absorb more amount of ions, and such kind of electrodes can be used for in future maybe for desalinating high concentrated solutions, maybe even seawater. But as of now, the CDI is not suitable for this purpose. Yeah.
Professor, when we conceive some technology, when we form some technology, when we suggest something new, better way, what comes to the mind is its commercial viability and its scalability.
Yeah.
So my next question is related to the scalability of the technology which you are suggesting. And what I mean by that is, like, is there any kind of constraint on volume of the water it can treat, and any other kind of constraint on it, and the viability on large scale? I mean, if this technology comes into the market, what is the scalability possible?
Okay, this particular technology is scalable, and the system that we have developed can provide water in the range of 200 to 500 LPH. I'm talking about one single cell can provide that kind of water. That means 200 liter per hour to 500 liter per hour, depending upon the input concentration of the dissolved solids. So, but if we can multiply these cells and scale up to the quantity we need, right? Now we are working on a 5,000 liter per day capacity unit. That means 5,000 liter per day capacity unit. But it is possible for us to bring it to 10,000, 20,000. It's quite possible. There is no problem on that. So we can scale it to any higher volume. So there is no problem like an RO system. However, we need to develop appropriate control system for this. So that is actually a challenge. So we are also developing a separate control system, a master systems to control this 50,000 liter per day capacity unit. So it can be scaled. And if you look at this advantage of this kind of a system is, right, if you look at the energy requirement, it is substantially less. If you compare with RO, the energy required here is an order of magnitude less. Right, it's less than 1 kilowatt hour per meter cube. And most of this energy is actually utilized for pumping water through the pre-filters. And we have certain pumps there to pump the water through the pre-filters and things like that, because that will offer some pressure drop. But if we have an overhead tank of 3 meter water head or 4 meter water head, even we can remove that and significantly reduce the energy requirement. And so this works based on DC, and it is also possible to integrate this system very easily with solar or wind. And so we can even install these kinds of system in remote areas. And another biggest advantage with the CDI system is the water recovery. The water recovery is very high here. So one of the system that we have installed in Amar Raja, the water recovery is around 97%, around 97%. So because their input TDS, it's not very high, so around 500 milligram per liter. But typically, if you look at the water recovery, it varies from 75 to 95%. Of course, it depends upon the TDS, the feed water TDS. So, but if in the case of an RO system, the recovery is only 20% to 60%. So we are losing a huge amount of water. So that is one of the significant, benefit of CDI system over RO system. We see several places we already have water scarcity, and we cannot afford to lose our drinking water in the name of treatment. So we need to have an alternate system. That's the reasons why we came forward with this. And this is a very, as I told you in the very beginning, it's an emerging technology. Now, the cost aspect, if you look at, and the water treatment cost is, if you look at the operating cost, is only less than 2 paise per liter, and much less than RO. For example, in the case of an RO, assume that an household RO, so typically one has to, there's a 10 liter per hour capacity unit if we compare. So typically the membrane, other cartridges will survive for a year, right? Maximum of an year. So an year, if we wanted to change all these units, there are some 4 or 5 units inside, it would cost around 5,000 to 6,000 rupees. So assume that we are treating at 20 liters water per day. So that means we are treating around 7,300 liters of water in a year. So we are spending around 6,000 rupees for that. So you can imagine what is the operating cost of these kinds of system, very close to around 71 rupee, right? So normally we don't look at all of these things. And what we do with all these cartridges tomorrow, right? All these cartridges, the so-called big giants who sell RO-based system don't have any mechanisms to collect it back, right? All this will go back to the environment. Who will take care of it? So this will be like a plastic bags tomorrow floating on our water bodies. So this is actually a very challenging, issues. So as a business person, their interest would be to increase the number of, selling of number of units. So they always promote use of these consumables, but nobody takes care of it. Takes care of this spent material. So then we also don't have a proper mechanisms to dispose it. These are the several issues that we need to discuss. So we need to have a system which is more sustainable, which pollute environment less, right? And which also don't waste our water, and it has less carbon footprint, less water footprint, right? So that kind of a system, that is what we need a country like India.
Okay, wonderful. Now, Professor, do you see that both the technologies, RO and CDI technology, can be used simultaneously to create what we can say hybrid water treatment system in future?
So whether we can use these two technologies together, right? So yes, it is possible to club this system for better water recovery, maybe. Like, for example, RO system can be used to treat reject water from CDI unit, right? And improve the water recovery. So you have a CDI unit that would treat certain amount of water, and assume that we have a 20% water reject, and that 20% water reject can be passed through CDA, because it will be a very concentrated solution, right? That cannot be treated with a CDA unit. So then we need to have, at present, we need to have an RO system. So maybe an RO system can be used to recover more water, and those kinds of applications may be used. So, and those kinds of combination of technology may help to improve the water recovery. In some cases, it can be also used as a pre-treatment unit. So depending upon our need and the cost involved, we can use CDI as pre or post treatment system. I think that is quite possible.
Okay. So, Professor, now after this discussion related to wastewater treatment and a lot of information which has come from your side, I'll bring to your attention your other research domains. And you have also done marvelous work on domains like smart cities and infrastructure. You have developed a brilliant product that is not only biocompatible and environmental friendly, but also from strength perspective, strength point of view, it offers 5 times greater tensile strength than what concrete offers. So please illuminate us more on your this particular research.
Yeah. So yes, you're correct. The product that we have developed, the sealant that we have developed, has high tensile strength of around 80 MPa, 80 Newton per mm square. A typical M30 concrete, the tensile strength would be around 3.8 Newton per mm square, right? So that means it's not 5 times, it is 20 times better than M30 concrete, right? So this product is entirely different from a CDI, and this product is developed for healing microcracks in concrete. So this, as I mentioned to you earlier, this product is derived from a biopolymer, and this biopolymer is actually derived from waste. So it's actually a waste to wealth kind of a concept that we have applied to develop this product. So then this biopolymer is modified with various other nanoscale materials like graphene-based materials. And there are certain porosity controlling agents. And we selected all these ingredients very carefully. And most of these ingredients that what we use in this materials, in this composite, are non-toxic. And we also have certain amount of calcium and magnesium precursor in this. So the beauty of this particular sealant is the sealant has the ability to solidify in alkaline environment and form a robust plug inside the concrete, right? So this is also very stable in alkaline environment and can bind with the concrete very firmly, right? Can form a covalent bond with concrete. Chemically, it can bind and form a very, very strong plug inside the concrete matrix. But in the conventional sealants has certain disadvantages. Of course, they are toxic in nature, derived from non-renewable material. And many of these, and some of the products that is available in the market takes long time. Sometimes we need a polymerizing agent to polymerize some monomers, right? And so some kind of a pressurized system is required to inject them. And so this material has, many other advantages over conventional sealants what is available in the market, and the cost is also significantly less. So we thought it has potential applications in healing microcracks in concrete. Now we talk about microcracks. Let us try to understand why we need a product like this, right? Why microcrack is we need to seal. So we know that the occurrence of microcracks in concrete is very common phenomena, and it requires serious care, serious attention is required. And this is actually an inherent property of any normal concrete. So we all know that, as I just mentioned, the tensile strength of concrete is very poor, right? Concrete is very poor in tensile strength.
Right.
So this is the reasons why we reinforce concrete for structural applications. We introduce steel, we introduce other, textile materials and things like that to improve the tensile properties of the concrete. Then only we can use it for structural application. So it is difficult to completely prevent the development of cracks on the surface of the concrete. So several types of cracks can form depending upon the environment in which the concrete is placed. So plastic shrinkage cracks, expansion cracks, drying shrinkage cracks, on maybe cracks due to chemical or environmental factors. Then cracking also due to loading, right? That also can, and non-uniform settling, and all this can happen. So the problem with the crack is all cracks are not unsafe, right? But these cracks can facilitate over a period of time. These cracks can, coalesce and then spread, and they can grow wider also. So all these cracks can then facilitate the entry of gases, corrosive gases, right? And water it can pass, then gases like oxygen, carbon dioxide, etc. So when these kinds of materials enters into concrete matrix, what will happen? The properties of the concrete change. They endanger the durability of the concrete and endanger the durability of the structure. So we need to seal the cracks on time. Then sometime if we are not sealing it on time, what happens is that, as I mentioned earlier, it grow wider and even expose the reinforcement to the outside environment. Right. And so once the reinforcement start, so that can leads to an accelerated corrosions.
Okay.
Then that can leads to, the complete collapse of the structure. So that's why we need to repair cracks on time. Okay. So several methods are available. If you see the literature, there are several methods available, techniques available, and several methods are developed globally to repair cracks. And among all these methods, injecting chemical grout or chemical grouting material into the crack is very well established and proven technology. But the problem with the chemical grout, as mentioned earlier, it's of course it is very useful material because of its high tensile strength, flexibility, and stretchability, and things like that. That's the reasons why it is widely used. But most of these chemical agents, such as epoxy resin or polyurethane or acrylamide, methacrylate, and these are toxic and not an eco-friendly material. And we also need to understand that we need to use these materials in large quantity, and cracks have to be repaired frequently. So another problem, as I mentioned earlier, this kinds of sealant are very effective in moist environment and do not form proper bonding with the concrete surface. So, and if you look at the carbon footprint of this kind of resins and things like that, it's much higher, right? Around 4 to 10 kilogram of carbon dioxide equivalent and things like that. So this is one of the issues with the conventional material. And we also need to understand that cracking is actually a perpetual problem. So we need to do this periodic maintenance. So periodic maintenance is very essential. So what we need is a material with low embodied energy. So that is the need of the and so a sealant made of renewable material is more suitable for this application, more sustainable compared to synthetic material. And no company in India manufactures sealant. Okay. And we import the product from abroad. At the same time, the demand for the product is huge in India, and a large chunk of our concrete structures are more than 10 years old. So that's why we thought this material
So, Professor, do we see entrepreneurial opportunity here? As you said, a lot of demand, but we are importing.
There is a good opportunity, to take this product to the market. And so we are started talking about this. We are also started collaborating with some of the people at IIT Madras to take this product to the market. Of course, we are not, so our area is entirely different, though this product is developed for concrete applications. So we works largely on water and wastewater purification. So we are thinking of transferring this technology to potential, customers. And of course, we are also working on now different kinds of sealant, modified forms of sealant. So we are trying to improve the properties of this sealant.
Okay. Professor, you mentioned in the beginning that in IIT Tirupati, you are also working on a very relevant domain, that is intellectual property rights. You are working on that also. And my next interaction point is related to filing of the patents only. I mean, filing of the patents in India, very less awareness how to file the patents and all. And there are so many budding researchers and scientists who do not have a clear idea about how to file patents and all. So I want to ask you something about this patenting only. How ticklish this entire process is?
Yeah, I think now people are now more aware of the importance of patenting and protecting their intellectual property, at least in institutions like IITs and NITs and things like that. And most of the good institute has a dedicated patent cell for helping faculty, students, and staff in patent application filing process, right? So people can also approach patent attorneys in drafting and filing applications. So there are government organizations that support these activities. For example, Kapila, right, Kalam Program for IP Literacy and Awareness, and NRDC's National Research Development Corporation, right? This is actually a unit of Department of Science and Industrial Research. So these Kapila and NRDC give complete support, right, for filing patents. And Kapila also support in terms of money, right? For each patent, they give a certain amount of money. And NRDC, actually, if you have an idea, we can approach them. So, they will take care of entire patenting process. Of course, there will be a patentability search and things like that. So, and they will even, take this, they are ready. They have, experts to take this to the market and, showcase the product or process to the potential customers. So there are a lot of opportunity. So my advice to the people is to protect the invention before putting it in the public domain. Even if the work is incomplete, there are options for filing provisional patent applications without a formal patent claim or prior art. So this is actually a temporary means of protecting IPR, and we get around 12 months to file the complete application. So this will help us to protect the invention and idea early. So those who have, most of the institutions now have the cells. If there are institutions, if they don't have such kind of facilities, so they can also approach to, this kind of an organization like Kapila and NRDC.
Professor, you are the right person. I can ask you this question. Many students during their graduation, post-graduation, doctorate, they feel like going for entrepreneurial ventures, or they want to have their own startups. So is it possible? I mean, IIT Tirupati provides that particular facility, that being the student of IIT Tirupati, they get some kind of advantage, or they can go for such kind of startups.
Yeah, so we have, as I mentioned to you, there is a institute has a dedicated center called Center for Sponsored Research and Consultancy. Take care of all these kinds of activities, right? A patent cell under the center takes care of filing patent filing, patent application filing, technology transfer, etc. So we also have a company, a non-profit company, a Section 8 company, to to help startup. So we promote potential, technologies, innovations. So we've also actually wanted to take it forward, and there is a system in place. So there are mentors available. There are incubation center available, pre-incubation centers available, and they'll get all the training. So we do a lot of promotion on these kinds of activity. So the center will provide all necessary support required to faculty, staff, and the students. And these kinds of facilities are available in all IITs.
So that can be easily done.
It can be easily done.
Yes, Professor. Now we have come to almost an end of this wonderful marathon session, which we had a lot of information from your side. But I'll end up with a couple of one or two more questions for you. One is related to the relevant research areas in your field of research work. Students are not very clear in which area they should proceed forward if they are looking for career in higher education or research or something. Like typically a civil engineer is not very clear, like which area should I pursue my master's or doctorate or research, so that after I graduate I get good opportunities in the industry and all. Can you suggest some such areas which a student can think of?
See, when you ask me the area, I would always want student to work in the area which I work, right? So if you ask this similar kind of questions, somebody else, they would
Yes, that is
a
true.
different area. So my suggestions to students is whatever area they wanted to work, they should identify the appropriate person, write to them, right? So if they wanted to work with us, a student can always write to me expressing their interest. Then we can give them appropriate guidance looking at their interest. So my email ID is shihab@iittp.ac.in. We are always looking for interested and motivated student to take work forward. But suggesting an area will not be a right thing to do in this kinds of.
Okay.
So that's what I feel. But of course, there are areas like this our country needs, right? We have a problem of when it comes to environmental related problems. So we have issues with water, we have issues with wastewater management, we have lot of issues with air pollutions, we have issues with the solid waste management. So we want a lot of young people to come forward and address this problem, because this is actually important for their own survival also as well. And there are a lot of opportunities. If we can come up with a good drinking water system, so they can, you can also generate huge amount of money. And so there are a lot of opportunities. There is no dearth of opportunity.
In fact, this entire interaction was focused on those areas only.
Yeah.
If some student will listen to this entire interaction in totality, he will suddenly get a lot of ideas. Professor, my last point of discussion is related to your prospective students. Whenever somebody listens to professors like you and they listen to your field of research and work, they get interested to work with people like you. My question to you is, what do you see in your prospective students? As somebody who wants to work under your guidance, maybe for internship, maybe for project, maybe for masters, maybe for doctorate. How he should groom himself, how should prepare himself, and what do you see in him?
Actually, there is no prerequisite of, but what is needed is a strong desire and motivation. Okay. That is more important to do research. Of course, we also look at analytical skills and domain knowledge. And these analytical skills and domain knowledge also matters. In addition to, one important thing is common sense. So that is extremely important in research. So, and I believe these qualities are essential to become a good researcher. So those who have motivation and those who have desire to pursue challenging problem, right? Especially in environmental area, they can always contact us. We would be happy to guide them and mentor them.
Wonderful. So that brings Professor to us to an end of this wonderful session. So,
Yeah.
Professor Shihabudheen, I am really thankful. You spared time this morning, and it was almost an hour. You were very patient, and you provided all the detailed answer to my queries. And I'm very sure whosoever will listen to it will get a lot of information from here. And I thank you for that. And I also wish you all the very best for your all academic and research endeavors. Thanks a lot, Professor Shihabudheen.
Yeah, thank you for arranging this interview meeting and enjoy the questions, and I hope I answered them satisfactorily. If you need more information related to the work that we are doing, please
Yes.
write to me. I'll again tell my email ID, that is Shihab, SHIHAB @ iittp.se.in. Thank you very much.
Thank you.